Now calculate the volume of CO2 gas at STP liberated when 25 grams of calcium carbonate is completely decomposed. Calculate the volume of CO2 gas at STP liberated when 25 grams of calcium carbonate is completely decomposed. So we have already know that when calcium carbonate is decomposed, it decomposes to give calcium oxide and carbon dioxide. So CaCO3 when decomposed, it gives us calcium oxide and carbon dioxide. Now the molecular weight of calcium carbonate, here calcium atomic weight is 40, carbon atomic weight is 12, here 3 oxygens are there. So the total of 3 oxygens, 3 into 16, it is 48. So when you add all the 3, you will get 100. So this is the 100 is the molecular weight of CaCO3. So calcium carbonate molecular weight is 100. Calcium carbonate molecular weight is 100. Similarly, calcium oxide, calcium is 40, oxygen is 16. Oxygen is 16. So calcium oxide molecular weight is 56. So the molecular weight of calcium oxide is 56. Here in CO2, carbon is 12 plus 2 oxygens, 2 16s, 32. 12 plus 32, it is 44. Now 44 plus 56 will be equal to 100. It should be always equal. Now what is the relation they are asking? When this shows that 100 grams of calcium carbonate decomposes to give 56 grams of calcium oxide and 44 grams of carbon dioxide. This 44 is the molecular weight of carbon dioxide. If we express the whole thing in grams, 100 grams of CaCO3 decomposes to give 56 grams of CaO and 44 grams of CO2. But in this problem they are asking the volume of CO2 gas at STP. 44 is the molecular weight of CO2. 44 grams is the gram molecular weight of CO2 or 1 mole of CO2. So 1 mole of CO2 at STP conditions, it will occupy 22.4 liters volume. Now this 44 grams of CO2 at STP occupies 22.4 liters. Now the thing, how to compare this? 100 grams of CaCO3 give 44 grams of CO2 or 22.4 liters of CO2 at STP. So they are asking the same thing. What volume of CO2 is liberated in the complete decomposition of 25 grams of CaCO3? Now here we have the relation, that is 100 grams of CaCO3 liberates 22.4 liters of CO2. 100 grams of CaCO3 liberates 22.4 liters of CO2. Because according to this equation, 100 is the molecular weight of calcium carbonate, 56 is the molecular weight of CaO, and 44 is the molecular weight of CO2. So when in the decomposition of calcium carbonate, the mass ratios are 100 grams of calcium carbonate decomposes to give 56 grams of calcium oxide and 44 grams of CO2. The same 44 grams of CO2 will occupy 22.4 liters at STP. So in other words, we can say that 100 grams of CaCO3 on decomposition, it can give 22.4 liters of CO2. So 100 grams of CaCO3 can give 22.4 liters of CO2 at STP conditions. Now they are asking the amount of CO2 that liberated and 25 grams. So 25 grams of CaCO3 can give how many liters? So 25 by 100 into 22.4, 25 4 times, 4 here, 5.6 times. So from 25 grams of CaCO3 on complete decomposition, you are going to get 5.6 liters of CO2. 5.6 liters of CO2. That is the volume of CO2 that liberated in the complete decomposition of 25 grams of CaCO3. Once again, here the problem is calculate the volume of CO2 gas at STP liberated when 25 grams of calcium carbonate is completely decomposed. The equation for the decomposition of CaCO3 is CaCO3 gives CaO plus CO2. CaCO3 gives CaO plus CO2. Now if you substitute the molecular weight of all the compounds, 100 is the molecular weight of CaCO3, 56 is the molecular weight of CaO, and 44 is the molecular weight of carbon dioxide. That means the mass ratios of calcium decomposition of calcium carbonate is as follows. That is 100 grams of calcium carbonate on decomposition gives 56 grams of CaO and 44 grams of CO2. Thus 44 grams of CO2 is said to be 1 mole because 44 is the molecular weight. So 44 grams will be the gram molecular weight or gram mole or simply as mole. So 1 mole of any gas at STP conditions, it will occupy 22.4 liters, that we call it as a gram molar volume. So the carbon dioxide volume in the decomposition of 100 grams of CaCO3 is 22.4 liters. So now they are asking the volume when 25 grams was decomposed. So if 100 grams of CaCO3 is decomposed, it produces 22.4 liters. For 25 grams, how many liters? 25 by 100 into 22.4, that is 5.6 liters. So 5.6 liters of CO2 gas is liberated in the complete decomposition of 25 grams of CaCO3. Problem: calculate the volume of O2 at STP required for complete combustion of or completely burn 12 grams of magnesium. We know the equation or the required for the above reaction. Magnesium burn in presence of oxygen to give magnesium oxide. Magnesium burn in presence of oxygen to give magnesium oxide. Now, here 1 magnesium, product side is also 1 magnesium, but 2 oxygens are there only 1 oxygen, so you have to write 2 here. To balance it, you have to put 2 here. 2 Mg plus O2 gives 2 MgO. This is the required equation, balanced equation. Required balanced equation. Now, according to this equation, 2 into 24 is the atomic weight of magnesium. 2 into 24 grams of magnesium is reacting with 32 grams of oxygen to produce magnesium oxide. So here they are asking the volume of oxygen at STP. So this 32 grams of oxygen will occupy 22.4 liters at STP. 22.4 liters at STP. That means this 48 grams of Mg requires 22.4 liters of O2 at STP. That is the ratio. 48 grams of Mg requires 22.4 liters of O2 at STP. Now what they are asking? The volume of O2 required for the burning combustion of 12 grams of mg. Here for 48 grams of mg, you require 22.4 liters. Then for 12 grams of mg, requires how many liters of O2? So 12 by 48 into 22.4, 4 times, so 5. So 5.6 liters of O2 gas is required for complete combustion of 12 grams of mg. Just simple. In any the stoichiometric problems, first you should observe what is the equation or the reaction. What is the reaction involved to solve the given problem? So generally they won't go for a new and unknown equations. Here they will give you a well-known reactions which are very familiar to you and which are within your syllabus, which are frequently discussed in the classrooms. They won't give you a new reaction, because if new reaction was given, even we are also unable to do it. So they won't give you, but they may give the equation or the reaction from any chapter in your syllabus. It may not belong to the particular topic which we are dealing. In some other topic, that reaction may present. So you should remember each and every reaction which was present in your syllabus. If you know those reactions, and if you are able to write the equation for the above said reactions, and if you are able to calculate the molecular weights of the compounds that were involved, then it is very easy to solve this type of problems. So if you go on practicing it, you will be adjusted and you will able to do any type of a chemical reaction.